Hello students, welcome to General Chemistry 1 Chem 1411 and today we are going to start with chapter 1, which is matter, measurements and problem solving. And here's the textbook that we are using for this course, The Principles of Chemistry, a Molecular Approach by Nivaldo Tro. So, what do you think is one of the most important ideas in all of the human knowledge? And if we limit ourselves only to the scientific answers, it would be that the properties of the matter are determined by the properties of the molecules and atoms. And what are these atoms and molecules? So atoms and molecules, they determine how matter behaves. So if they are different, the matter would be different. So basically the properties of the water molecule will determine how water molecule behaves, and the properties of the sugar molecule will determine how sugar behaves. The understanding of matter at molecular level gives us this unprecedented control over the matter. So let's define atoms now. Atoms are submicroscopic particles which make the fundamental building block of the ordinary matter. And free atoms are rare in nature. They instead like to bind together in a specific geometric arrangement to form molecules. So here is an example of a water molecule. So this is actually a model for water molecule, and the red ball here is representing oxygen atom, and these two gray balls are representing the hydrogen atom. So the liquid water is composed of water molecules, and each molecule of water, which is H2O, so the formula for water is H2O, and each molecule contains two hydrogen atoms and one oxygen atom, which are held together by a chemical bond to form the water molecule. So if we want to understand the substances around us, we must also understand the atoms and molecules which make these substances, and that's the goal of chemistry. So chemistry is a science which tries to understand the behavior of matter by studying the behavior of atoms and molecules. And here is an example of graphite and a diamond, and see how they are both made up of carbon atoms, but the structure, the way these atoms are arranged, determines the properties of these graphite and diamond. So in graphite, these atoms, the carbon atoms, they are arranged in sheets, whereas in carbon atom, they are all bound together by this three-dimensional structure, and that gives it rigidity to the structure, and diamonds are hard, they cannot be easily broken. So now we're going to talk about the scientific approach to knowledge, and here is a schematic to explain the scientific approach. So the approach to a scientific knowledge is empirical. What it means is it has two aspects to it. It's based on the observation and experimentation. So you observe something, you experiment it, and then there are certain steps that you follow in a scientific approach. So a scientific method is a process for understanding nature by observing nature and its behavior, and by experimenting to test those ideas or hypotheses. So the key characteristics of a scientific method include observation, formulation of a hypothesis, experimentation, and formulations of law and theories. So you observe, then you hypothesize, then you perform tests or experiments, then you confirm those results to confirm the hypothesis. And when you revise these, you can form laws, and when the hypotheses are confirmed, you can formulate theories which are again experimented or tested by performing experiments. If any observation changes, then the theories can change. So let's look at each in detail. So observation is also referred to as a data sometimes, and they are the descriptions about the characteristics or behaviors of the nature. So what you notice, so for example, Lavoisier, he noticed that there was no change in the total mass of the material within the container during combustion, and that led to formulate hypotheses. So observations lead scientists to formulate hypotheses. Hypothesis is a tentative interpretation or explanation of the observations. So for example, Lavoisier explained his observations on combustion by hypothesizing that a substance burns. When a substance burns, it combines with a component of air, and we know combustion is a reaction in the presence of air. A good hypothesis is falsifiable. What it means is the results of an experiment may support a hypothesis or prove it wrong, in which case the scientist then modifies or discards the hypothesis. What are the scientific laws? So a brief statement which summarizes the past observation and predicts the future observations. So for example, law of conservation of mass. So law of conservation of a mass talks about, as the name suggests, conservation of a mass. It says that the matter is neither created nor destroyed in a chemical reaction. So the mass is conserved. It remains the same. So it allows you to predict the future observations, so you can test the law again with experimentation. So you can go back to the schematic that I show, or the flow chart that I showed you, to verify these statements about each term that we are learning. Unlike civil or governmental laws, you cannot choose or choose to violate a scientific law. If it is a scientific law, it will be true. Like the law of gravity holds true, right? You do not change it from place to place. It's universal. Theories, on the other hand, is more well-established hypothesis. Okay, so they can so when the hypotheses get established with experimentation, they can form a scientific theory. So scientific theory is a model or the way nature is, and it tries to explain not merely what nature does, but why does it happen. So theories are validated by experiments, as I said before. They can be tentative. They can never be conclusively proven, because some new observation or experimentation always has the potential to reveal a flaw or to discover something new. The general explanation for the characteristics and the behavior of the nature is predicted by the theory, or is described by the theory. The theories models the nature. One of the theories that we are going to study later in the class is going to be Dalton's atomic theory. And theories, as I said before, they can be used to predict future observations. So theories can be tested by performing experiments in the labs. So let's look at some conceptual question, and they will align with your textbook. So it's a good idea to learn a concept and then check, did we understand that? So what experiment best explains the difference between a law and a theory? So here are your 3 choices. Pause your video and think about it. And what's the difference between the law and the theory? So a law summarizes a series of relative observations, and theory gives the underlying reason for why does it happen. So as we said, chemistry is a study of matter. So we are going to now classify this matter. Matter is anything that occupies space and has a mass. So your textbooks, the desk, the chair, our bodies, everything is composed of, all these things are composed of matter. And we can classify matter according to its state or its physical form and its composition. So what are the basic components that make it? So matter can be classified as a solid, liquid, or gas based on what properties it exhibits. And these matter changes from solid to liquid to gas with increasing temperature. And a great example here is water. So if you decrease the temperature or if you freeze water, it becomes a solid, ice. And if you increase the temperature, the liquid water becomes a gas, right? It forms steam or water vapors. So it changes or increases with the matter can change with increasing temperature. So ice can become liquid water, can become a gas. So here's an example of all these 3 states, and you're also given the molecular view of solids, liquids, and gases. So here is a solid, you can visually see it, more structured, more ordered. Liquid, you see these atoms are not as tightly packed as in the solid. They have some space in between, which gives it room to move around. And then you have gaseous matter where the atoms are separated by a distance, right? They're far away from each other. And that's how the gas would look like. So let's look at each in detail. A solid matter, as we saw in the earlier figure, or as you see in the diamond here, the atoms or molecules are packed close to each other in a fixed location. So because there is not a lot of space to move around, the solids can vibrate, but they tend to have fixed volume and rigid shape. Examples are ice, aluminum, diamond. Solids can then further be classified as crystalline or amorphous. Crystalline, as the name suggests, is the case where the atoms or molecules are in a pattern with a long range repeating order. So like here you see this pattern of carbon atoms in the case of diamond. So diamond is an example of a crystalline solid, or a table salt is made up of those fine crystals. The second classification of solid matter is amorphous. And amorphous is something where you do not have this long range order. So for example, glass or plastic or something which is powdery. Liquid matter, in the liquid matter, as we saw in the earlier figure, the atoms are not very close as compared to the solid. So they are free to move, and because of that, the liquids have fixed volume, but they do not have fixed shape. They take the shape of the container. Example is water, alcohol, gasoline, all substances are liquid at room temperature. Gaseous matter. In gaseous matter, look around the room in where you are sitting, surrounded by the gas. So in gaseous matter, atoms or molecules have a lot of space between them, and they are free to move relative to one another, and these qualities make gases compressible. So here, if you see on the right hand side, you've shown two examples. On the top part, you have a container, and then you have a piston, and you have a solid structure there. You're trying to apply pressure or force, and the solid is not compressible. Whereas when you look at the gas here, you see there is a fixed volume when the pressure is less, but when you apply more pressure or when you increase the pressure, you see there is a decrease in the volume. So these molecules, or the gas molecules, are getting compressed. So that's what happens in the gaseous state or gaseous matter. The classification of matter by components. So as I said, matter can be classified as with the state or according to its composition. So according to its composition, a matter can be classified as element, compound, and mixture. So here's a great diagram where you can classify this matter. So matter, if it has a does it have a variable composition? No, then it's a pure substance. Pure substance is separable into pure substance. If it has a variable composition, then it is a mixture. And then mixture can further be classified as heterogeneous or homogeneous, depending on if it is uniform or not. And the pure substances, if they can be separable into simpler substances, if the answer is no, then it is an element, as you see in the periodic table, elements in the periodic table. And then you have, if they can be separated into simpler substances, then they're classified as compound. For example, water, which is made up of hydrogen and oxygen. Element is a pure substance which is not separable. For example, helium gas. All the atoms are helium atoms here. Heterogeneous mixtures are where you can separate the two, like you can visually see that the mixture is not uniform throughout. So for example, wet sand, you can see water as well as the sand particles. And homogeneous mixtures, the great example is your tea with sugar. So even though there are different components there, but visually it looks uniform throughout. The tea looks uniform throughout. You don't say, oh, this is the sugar and this is the tea. It looks uniform to you. So in the next few slides, you will see the same explanation. So first division is whether it's a pure substance or a mixture. And a pure substance is made up of, as I said before, only one component, and its composition is invariant. And mixture is composed of two or more components in proportions that can vary from one sample to another. The two types of pure substances are elements and compounds. And the way we divide them into elements and compound is whether they can be separated or broken down into simpler substances. Elements do not, compounds can be broken down. So elements, as I said, cannot be chemically broken down. They are the basic building blocks of matter. For example, any single type of atom like helium, your gold atom, or your gold, or anything that has just a single type of atom. Compound, two or more elements in a fixed definite proportion. So for example, water, sugar, etc. Mixtures, two categories: hetero, that means not uniform; homogeneous means uniform. So how uniformly do they mix? So heterogeneous mixture has variable composition from one region to the other. They're made up of multiple substances whose presence can be seen. So salt and the sand mixture, or water and the sand. And the homogeneous mixture is where it's made up of multiple substances, but to your eyes, it looks like one substance. For example, sweetened tea or salt dissolved in water. So that's homogeneous. Or when you have this jewelry where you have two different elements like gold and silver could be mixed, but you don't, visually you can't say, oh, this part is gold and this part is silver. It looks uniform. And that's the homogeneous mixture. What do they have here?